We all know reading is more than just looking at words on a page, right? I mean, we've all had that experience where you kind of have to reread a sentence a few times and then suddenly it clicks.
Yeah, totally. It's like something shifts in your brain and it all makes sense.
Exactly. And that deeper level of understanding, that's not just about your eyes working. That's where these fascinating mental abilities come in, what we call executive functions. They're like the behind the scenes directors of our thinking.
Absolutely. And that's exactly what we're going to dive into today, these executive functions and the connection to reading comprehension. We're taking a deep dive into some really interesting research by Reese Butterfuss and Panayota Kando, published in Educational Psychology Review.
So, our mission today is to unpack how and when these executive functions, things like updating, inhibition, and shifting, really make a difference in how well you grasp what you're reading. We want to give you that shortcut to understanding this crucial link between your mental processes and getting the most out of the text.
And just to lay the groundwork, we'll focus on those three key executive functions: updating, inhibition, and shifting. Updating is all about actively monitoring and keeping the information in your working memory, like refreshing a web page in your mind.
Got it.
Then there's inhibition, your brain's ability to, actively suppress those dominant responses or irrelevant thoughts. It's like hitting the mute button on distractions.
Makes sense. And then what about shifting?
Shifting is all about that mental flexibility, being able to switch between different tasks, operations, or even mental sets, like seamlessly transitioning between reading for pleasure and then switching gears to analyze a complex academic paper.
Okay, so we have updating, inhibition, and shifting. And even though we're talking about them separately, it's important to remember they all kind of work together, right? They're like different parts of a well-oiled machine, each playing its role in the overall performance.
Exactly. And there's actually a growing idea that there's even a common underlying ability to these functions, often referred to as common EF, which is all about maintaining those task goals and kind of biasing your processing accordingly.
Interesting. So it's not just that they work together, but they might even share some fundamental mechanisms.
Right. Now, it's fascinating to think about the bigger picture here. We have all these existing models of reading comprehension, different ways of understanding how we construct meaning from text.
Like those frameworks that describe how we piece together information as we read along, building our understanding bit by bit.
Precisely. And while those models have been incredibly useful, they haven't always explicitly incorporated these executive functions into the equation. But as Butterfuss and Kendo point out, and as we'll see throughout this deep dive, there's strong empirical evidence that these mental abilities play a significant role.
Okay, so let's start unpacking these executive functions one by one and how they relate to reading comprehension. First up is updating. Can you help us understand what that actually looks like when we're, say, reading a book or an article?
Sure. Updating, as we mentioned earlier, is closely tied to working memory. You might be familiar with Baddeley's model of working memory, which proposes several components. For our discussion on reading, the most relevant ones are the phonological loop, which handles that verbal information like the words we're reading, and then there's the central executive, which acts like a manager, overseeing and coordinating all the information coming in.
So the phonological loop is kind of like that inner voice that repeats the words as we read, and the central executive is making sure everything runs smoothly.
Exactly. And research has shown that how well someone performs on tasks that measure these working memory components, like remembering lists of words or doing mental calculations, can actually predict how well they comprehend complex sentences and even longer passages of text. If someone has difficulty with either the phonological loop or the central executive, it can really impact their understanding.
Makes sense. If you can't hold on to the beginning of a sentence by the time you reach the end, or if you can't juggle multiple ideas at once, it's going to be tough to get the full picture. Now, the article brought up an interesting point about working memory and updating. Are they essentially the same thing, or is there a distinction?
That's a great question and an important distinction to make. Some researchers consider working memory itself to be a type of executive function, while others view it more as a supporting system. And the way we typically measure them can be different too. We often use what are called complex span tasks to measure working memory, where you have to remember something while doing another task at the same time. For example, you might be asked to remember a list of words while simultaneously solving math problems. Updating, on the other hand, is often measured with tasks like the end-back task or keep-track tasks, where you have to constantly monitor and revise information based on new input.
So you might see a series of letters, and you have to remember if the current letter matches the one you saw 2 letters ago.
Precisely. And what's interesting is that studies have found rather weak correlations between performance on these different types of tasks, those complex span tasks for working memory, and the end-back or keep track tasks for updating.
So just because you have a good memory for lists doesn't necessarily mean you're a pro at constantly updating your understanding as you encounter new information.
Exactly. And a study by Radvansky and Copeland really highlighted this. They found that while traditional working memory tasks weren't great at predicting how well someone could update their mental model of a story as they read, a task specifically designed to measure updating was a much stronger predictor. This suggests that updating may be that crucial link between your more general working memory capacity and your reading comprehension skills.
So it's not just about how much information you can hold in your mind at once, but more about how effectively you can revise and integrate new information as you go.
Right. And the consequences of poor updating can be pretty significant for comprehension. One major issue is that irrelevant information can linger in your working memory, leading to what are called intrusion errors. It's like when you're trying to follow a complex plot in a novel, but you keep getting sidetracked by details from earlier chapters that are no longer relevant.
Ah, so it's like your mental workspace gets cluttered, making it harder to focus on what's important at that moment.
Precisely. And Coretti and colleagues even distinguished between immediate intrusions, which are those things you should have discarded right away, and delayed intrusions, which are things that were relevant for a while but then became irrelevant. They found that less skilled readers tend to make more of those delayed intrusion errors.
So they have more trouble letting go of information that's no longer needed.
Exactly. Which suggests they have difficulty controlling the activation of relevant information in working memory, because that irrelevant information is still kind of hanging around.
Yeah.
And it's not just about the sheer amount of information you can hold. Palladino and others found that it seems to be more about how much irrelevant information needs to be inhibited. The more irrelevant stuff there is, the more difficult it is for less skilled readers to keep track of what's important.
It's like trying to find a specific document on a messy, cluttered desktop, right? You know it's in there somewhere, but all the other stuff gets in the way.
Perfect analogy. And this difficulty with updating doesn't just impact remembering the words on the page. It can also affect your ability to make inferences and integrate your prior knowledge with the text. Garcia Madruga and his team found that updating skills in children actually predicted their ability to make those inferences, those conclusions that aren't explicitly stated in the text, and to connect what they were reading to what they already knew about the world. So if you can't effectively update your mental model of the text, you might miss out on those deeper layers of meaning.
You might just get stuck at a surface level understanding rather than really engaging with the ideas. Now, the article also mentioned a study that didn't find a direct link between a specific type of updating task and reading comprehension in children. Why might there be these differences in findings?
That's a really important point to consider, and it highlights the complexity of this relationship. Moiselar and de Jong suggested that the reason for that particular finding might be the difference in the complexity of the updating demands between a very focused updating task in the lab, like remembering a few words, and the constant dynamic updating that happens during real-world reading.
Right, in real reading, you're not just remembering isolated bits of information. You're constantly connecting new information to your vast storehouse of knowledge, making inferences, adjusting your understanding as you go.
Precisely. And the demands on working memory and updating are much higher in those real-world reading situations. The article also points out that updating and reading isn't solely determined by a single factor. Both domain general factors, like your overall processing efficiency and your ability to manage information in working memory, as well as domain-specific factors like your verbal skills and how well you can update specific types of information, seem to play a role.
So it's not just about how good your working memory is overall, but also about how well you can handle the specific demands of verbal information processing.
Exactly. And there's some evidence that tasks measuring verbal span, that is, your capacity to remember sequences of spoken words, actually differentiate skilled and less skilled comprehenders better than those more general working memory tasks.
Interesting. So those verbal memory skills seem to be particularly important for reading comprehension. Now, is updating equally crucial for all aspects of reading comprehension, or does it play a more significant role in certain situations?
That's another interesting question. Patoki and colleagues found that updating predicted inferential comprehension, that deeper level of understanding where you're drawing conclusions and making connections, but not so much for literal comprehension, which is more about just recalling facts directly stated in the text. This suggests that updating might be more crucial in those complex reading situations where you're really having to work to integrate information and make sense of nuanced meanings.
So when you're reading a dense philosophical treatise or trying to analyze a complex scientific paper, those updating skills are going to be especially important.
Absolutely. So to summarize our exploration of updating, the key takeaway here is that it's not just about holding information in your mind, but about actively managing and updating that information as you read, keeping the relevant stuff in focus and filtering out what's no longer needed. This allows you to construct a clear and coherent representation of the text, which is essential for deep comprehension.
It's like having a mental filing system that's constantly being reorganized to make space for new information and prioritize the most important pieces.
Precisely. And that brings us to our next core executive function, inhibition, which is all about filtering out those irrelevant thoughts and distractions so we can stay on track.
Now, when we talk about inhibition in the context of reading, what exactly do we mean? How does this mental ability play out as we're engaged with the text?
Inhibition is essentially your brain's ability to actively suppress those dominant automatic responses that might interfere with your goals. It's like having a mental gatekeeper that helps you stay focused and avoid getting sidetracked by irrelevant thoughts or impulses.
So it's like having that internal voice that says, hey, focus, don't get distracted by that shiny object over there, stay on task.
Exactly. And researchers like Friedman and Miyake have pointed out that inhibition isn't just one single ability. It involves several different facets, like active inhibition that's intentionally stopping yourself from doing something, resistance to intrusions, or what we call proactive interference. That's when old information or habits keep popping up and interfering with your current task. And resistance to distraction that's tuning out those external or internal distractions that can pull your attention away from what you're trying to focus on.
So you're battling distractions both from within your own mind, those irrelevant thoughts and memories, and from the outside world.
Exactly. And the article discussed a really helpful taxonomy by Hasher and colleagues that breaks down inhibition and working memory into three main types: access, deletion, and restraint.
Okay, can you explain what those look like in action as we're reading?
Absolutely. Access inhibition is like that mental gatekeeper we mentioned earlier, preventing irrelevant information from even entering your working memory in the first place. So as you're reading, it helps you filter out those distracting details or thoughts that aren't important for understanding the text. Then there's deletion, which is your ability to remove information from your working memory that was relevant at one point but is now outdated or no longer needed.
So if you're reading a mystery novel and you initially suspect one character but then get new clues that point to someone else, you need to delete that initial suspicion so it doesn't cloud your judgment.
Exactly. Good deletion skills mean you can efficiently update your understanding as you encounter new information, without those old, irrelevant bits clinging on. And finally, restraint is about suppressing those incorrect or automatic interpretations of what you're reading so you can consider other possible meanings and arrive at a more accurate understanding.
So if you encounter a word with multiple meanings, restraint helps you avoid jumping to the most common or obvious meaning, and instead consider the context to figure out the intended meaning.
Precisely. Now, how do these different types of inhibition play out in actual reading comprehension? Well, Magistry and her team use tasks that assess these inhibitory abilities, like the hailing task, which involves both generating words and suppressing obvious responses. And they also looked at how many intrusive thoughts popped up in people's minds during a listening task.
So it's like you're given a sentence with the last word missing, like the cat chased the, and you have to come up with a word that fits. But then in another part of the task, you have to come up with a word that doesn't fit.
Exactly. And what they found was that those who were more skilled comprehenders were faster at deleting irrelevant verbal information and better at restraining those automatic responses compared to less skilled readers. They also observed that these inhibitory functions tend to improve as people get older, which suggests that they develop over time with experience.
So as we mature and gain more experience with language and reading, our ability to control those mental distractions gets better. But the article also mentioned some studies that showed slightly different results, right? Not all studies found the same clear-cut relationship between all types of inhibition and reading comprehension.
That's right. There have been some contrasting findings, which highlight the nuances of this relationship. For example, Chiabi and colleagues found that less skilled readers seem to have more difficulty with access and restraint, so letting in irrelevant information and having trouble suppressing those incorrect interpretations, but not necessarily with deletion, that is, removing information that was already in their working memory.
So once the information was in their minds, they could deal with it, but they had more trouble filtering it out in the first place.
Exactly. Interestingly, they also found that even some older, skilled readers had difficulty with access inhibition. This might indicate that as we age, certain aspects of inhibition might become more challenging, even if our overall comprehension skills are still strong.
It also points to the importance of not oversimplifying this relationship. Different aspects of inhibition might play different roles at different ages, and even within the same individual, some aspects might be stronger than others.
Absolutely. But overall, the research consistently shows that inhibition in its various forms is incredibly important for managing that flow of information in our minds as we read. It helps us tune out distractions, whether they're external noises or those internal, irrelevant thoughts that pop up, and it allows us to stay focused on what's most important for understanding the text.
It's like having a mental decluttering system that keeps our workspace clear so we can concentrate on building that coherent understanding of the text.
Right. And Barella and her team took an even closer look at different types of inhibition. They found that less skilled readers had more trouble with what's called resistance to proactive interference, which, as you mentioned earlier, is that tendency for old, irrelevant information to keep interfering with your ability to process new information.
So it's like you're trying to learn a new language, but words from your native language keep popping into your head, making it harder to focus on the new vocabulary.
Exactly. That's proactive interference, and less skilled readers seem to experience more of it, which can really disrupt their comprehension. However, when they looked at other types of inhibition, like prepotent response inhibition, which is measured with tasks like the Stroop test, where you have to suppress the automatic response of reading the word and instead name the color the word is printed in. The findings in relation to reading comprehension have been more mixed, especially across different age groups.
Right. Some studies found a link between prepotent response inhibition and reading comprehension, while others didn't. And those that did find a link sometimes found it was stronger in certain age groups than others.
Exactly. This suggests that those developmental factors might play a role. Maybe certain aspects of inhibition are more critical for reading comprehension at certain stages of development than others.
The article also discussed Gernsbacher's work, which focused on the role of suppression in how we understand words and sentences. Can you elaborate on that a bit?
Certainly. Gernsbacher's research really highlighted how we use inhibition to suppress irrelevant meanings of words as we encounter them in a sentence. For example, you read the sentence, "The bank was muddy." Skilled readers automatically suppress the financial meaning of bank and quickly focus on the riverbank meaning based on the context of the sentence. Less skilled readers seem to have more trouble with this automatic suppression, which can momentarily slow down their processing and potentially lead to misinterpretations if they briefly consider the wrong meaning before correcting themselves.
So they might initially think about a financial institution being muddy, which doesn't quite make sense before they realize it's talking about a riverbank.
Exactly. And those brief moments of confusion can add up and make the reading process less fluent and less efficient. Other research, building on Gernsbacher's work, has shown that less skilled comprehenders tend to make more of those intrusion errors in working memory tasks, which again points to this difficulty in suppressing irrelevant information and using their mental resources efficiently.
So they're not as good at keeping those irrelevant thoughts or meanings at bay, which can make it harder to build a coherent understanding of the text.
Right. And it's not just about those individual words and sentences. Our ability to inhibit might even affect how much our minds wander when we're reading. McVeigh and Kane suggested that attention control, which is closely related to inhibition, might indirectly influence reading comprehension by affecting how much we drift off topic while we're supposed to be focused on the text.
So if you're good at inhibiting those irrelevant thoughts and distractions, you're less likely to find your mind wandering to what you're going to have for dinner or that email you need to respond to.
Exactly. Skilled comprehenders might be better at suppressing those internal distractions and maintaining that focus on the text, which would obviously benefit their comprehension.
So it's like having a mental shield that protects your focus from both internal and external distractions.
Exactly. Inhibition, in all its various forms, really seems to be a crucial skill for managing that flow of information, keeping our mental workspace clear, and ensuring that we're processing only what's relevant for understanding the text.
It's like a mental Marie Kondo, tidying up our cognitive space and making sure that everything that sparks joy, or in this case, understanding, is front and center.
Perfect analogy. Now let's move on to our third core executive function, shifting, which is all about cognitive flexibility. How does our ability to switch our focus and adapt our thinking relate to reading comprehension?
Well, as the article pointed out, there's actually been comparatively less research on shifting in reading compared to updating and inhibition, and the findings we do have are a bit more varied. But the basic idea is that shifting is about being able to switch between different tasks, mental operations, or even perspectives, that cognitive flexibility we talked about earlier.
And you can easily see how that might be relevant to reading, which isn't just this single static activity. As we read, we're constantly shifting our attention between different aspects of the text, the sounds of words, their grammatical structure, their meanings, and we might also be switching between different reading strategies depending on our goals, whether we're skimming for the main idea or carefully analyzing a complex argument.
So sometimes we're focusing on decoding the words, sometimes we're paying more attention to the grammar, and sometimes we're really trying to grasp the deeper meaning and make inferences.
Exactly. And being able to seamlessly shift between those different levels of processing is crucial for fluent and effective reading comprehension.
The article also introduced this interesting concept of graphophonological semantic flexibility, which sounds like a real mouthful. What does that specifically refer to in reading, and why is it important?
It basically refers to the ability to flexibly consider both the sounds of words, that's the graphemological part, and their meanings, the semantic part, and to switch between those two aspects effortlessly. Cartwright's research has shown that this specific type of flexibility is a significant contributor to reading comprehension across different reading levels, even when you account for things like a person's overall cognitive abilities and their age.
So it's not just about knowing how to sound out words or understanding their definitions, but also being able to smoothly integrate those two aspects as you're reading.
Exactly. Sometimes, a word might sound like one thing, but in the context of the sentence, it means something completely different. Or you might need to access different layers of meaning for the same word as the text unfolds. Being able to shift back and forth between those sound-based and meaning-based representations is crucial.
So if you see the word tear in a sentence, you need to be able to quickly determine if it refers to crying or a rip in a piece of paper based on the surrounding words.
Precisely. And Guajardo and Cartwright found that both general cognitive flexibility and this specific graph-phonological semantic flexibility accounted for unique variance in reading comprehension. This suggests that being able to juggle multiple aspects of the text simultaneously is really key to grasping the overall meaning. On the other hand, if you're too rigid in your thinking and can't easily shift between these different aspects, it can really hinder your ability to construct a coherent understanding of what you're reading.
It's like you're trying to solve a puzzle, but you can only see one piece at a time, instead of being able to see how all the pieces fit together.
That's a great analogy. And there's some evidence that this ability to shift focus might even play a role in how we access and utilize our vocabulary knowledge as we read. Cartwright and colleagues found that cognitive flexibility seemed to help explain the relationship between the size of young children's vocabularies and how well they could comprehend what they read.
So it's not just about knowing a lot of words, it's also about being mentally agile enough to activate the correct meaning of a word based on the context, especially when a word has multiple meanings or sounds similar to other words.
Right. It's about being able to quickly and efficiently retrieve the most appropriate meaning for a given situation. And that requires cognitive flexibility.
Fascinating. So shifting plays a role in those more fundamental reading skills, like decoding and accessing word meanings, but it also seems to be involved in those higher level comprehension processes, like making inferences and adapting our reading strategies.
Precisely. And the article touched on some other potential ways shifting might be involved in reading comprehension. For example, it might help us deal with ambiguous sentence structures or multiple interpretations of a text, allowing us to consider different possibilities and arrive at the most accurate understanding. It might also play a role in how we process spoken language, helping us keep track of who's saying what and integrating information from different speakers.
It's like being able to mentally switch between different channels of information as we're listening to a conversation or reading a dialogue.
Exactly. Now, there was one interesting finding that being really good at rapidly switching between very simple tasks didn't necessarily predict how well someone would comprehend text later on.
So just because you can quickly switch back and forth between sorting cards by color and then by shape doesn't mean you're going to be a great reader.
Right. And Altemeyer and her team suggested that while this rapid automatic switching might be important for some basic reading skills, like quickly recognizing letters and sounding out words, those more complex aspects of comprehension, like making inferences or summarizing the main idea,
Yeah.
might rely more on other executive functions or a more deliberate type of shifting that involves higher-level planning and decision-making.
So it might be that different types of shifting abilities are involved in different aspects of reading.
Exactly. And it's not just that there are different types of shifting. It also seems that shifting doesn't operate in isolation. Its impact on reading comprehension might actually depend on the demands being placed on our other executive functions, like updating.
So how much we need to shift our focus might depend on how much we also need to update our understanding as we read.
Precisely. Potocki and colleagues found that the contribution of shifting to reading comprehension actually varied depending on the updating demands of the working memory tasks they were using. When the updating demands were lower, shifting played a more prominent role in predicting comprehension. But when the updating demands were higher, the contribution of shifting seemed to be less pronounced.
So it's like your brain has a limited amount of cognitive resources to devote to these tasks. And if a lot of those resources are being used for updating, there might not be as much left over for shifting.
That's a possible interpretation. And again, it highlights how interconnected these different executive functions are and how they're constantly interacting and influencing each other as we engage in complex cognitive tasks like reading.
So even though there are still some unanswered questions about exactly how shifting contributes to reading comprehension, it seems safe to say that being able to flexibly switch between the sounds and meanings of words, adjust our reading strategies, and consider different interpretations of the text is important for both those foundational reading skills and those higher level comprehension processes.
That's a great summary. Now, as we bring all of this together, what are the main takeaways about the role of these executive functions in our ability to understand what we read?
Well, the overarching message seems to be that updating, inhibition, and shifting aren't just these abstract cognitive concepts. They are actively and essentially involved in how well we make sense of text. They're like the mental tools that allow us to construct meaning from the words on the page.
And as Butterfuss and Kende point out, it's really interesting that despite this growing body of evidence highlighting the role of EFs in reading comprehension, many of the prominent models of reading haven't fully integrated them into their explanations.
So there's still a lot of work to be done in terms of refining our understanding of how these different mental processes work together to support reading comprehension.
Absolutely. And one of the big areas for future research is really understanding the interdependencies between those different executive functions. We know, for example, that being able to update information effectively often relies on your ability to inhibit irrelevant information. And as we just discussed, the contribution of shifting can depend on how much updating is required at the same time. Unraveling these complex interrelationships is a key step in getting a more complete picture of how our minds make sense of written language.
It also seems important to consider the role of executive functions when we're designing and interpreting assessments of reading comprehension. The article mentioned that some types of tests might unintentionally tap into these executive functions more than others, and that even the type of material we're reading, like whether it's a fictional story or a technical manual, might place different demands on those cognitive skills.
Absolutely. And that same careful consideration needs to be applied to how we measure the executive functions themselves. Each of these, updating, inhibition, and shifting, is not a single monolithic ability. They each have different facets or components, and the tasks we use to measure them might tap into those different aspects to varying degrees. There can also be some overlap with other cognitive skills, like attention or working memory. So we need more precise ways to assess these abilities to really understand their unique contributions to reading comprehension.
So it's a two-way street. We need to be mindful of how our measures of reading comprehension might be influenced by executive functions, and we also need to be mindful of how our measures of executive functions might be influenced by other cognitive skills. It's all very intertwined.
Precisely. But despite those complexities, the research is quite clear that understanding the role of executive functions can be incredibly valuable for explaining why some individuals are more skilled readers than others and how those reading abilities develop over time.
It can help us understand the cognitive underpinnings of those individual differences we see in reading comprehension skills.
Exactly. The authors even propose that these three executive functions we've been discussing, updating, inhibition, and shifting, might be analogous to the attentional control processes that are considered so crucial in the simple view of reading, which is a prominent model that explains reading comprehension as the product of decoding skills and language comprehension abilities.
So, just like attention helps us focus on the relevant aspects of language as we're decoding and comprehending, these executive functions help us manage the information flow and maintain that cognitive control that's necessary for successful reading comprehension.
That's a great way to think about it. And it's not just these three core executive functions either. The article briefly mentioned that those higher level executive functions, like planning, organizing, and goal setting, likely play a role as well, particularly when we're dealing with very lengthy or complex texts that require us to strategize and monitor our comprehension over an extended period of time.
So, when you're reading a dense textbook chapter or a long research article, those higher level planning and organization skills are going to come into play to help you stay on track and make sure you're meeting your reading goals.
Absolutely. And this whole discussion really aligns with that broader movement in education and cognitive science towards understanding those higher level thinking processes that are so crucial for deep comprehension, critical thinking, and meaningful learning. It's not enough to just be able to decode words and know their definitions. We need these executive functions, these mental management skills, to truly engage with complex ideas and construct lasting knowledge.
So, the takeaway for educators and anyone interested in improving reading comprehension is that we need to go beyond just focusing on those basic decoding and vocabulary skills and really think about how to support the development of these executive functions.
Absolutely. And in terms of future directions for research, there's a real need to refine our existing models of reading comprehension to explicitly incorporate these executive functions into the equation.
So, we need to update our models of reading to reflect what we're learning about the crucial role of these cognitive processes.
Precisely. And by including EFs in our models, we can gain much more nuanced insights into why individuals differ in their comprehension abilities and how those cognitive processes interact with different reading situations and different types of text to support or sometimes hinder that deeper level of understanding.
It could really help us personalize instruction and interventions to target those specific cognitive skills that might be holding someone back. Now, the article concluded with a really relevant real-world example about how executive functions, particularly inhibition, might be especially important when we encounter information that challenges our existing beliefs, especially in today's world of information overload and misinformation. Can you elaborate on that a bit?
Absolutely. That's a really crucial point. Butterfuss and Candia's own research has shown that the ability to inhibit prior beliefs plays a key role in how successfully we can revise those beliefs when we encounter new information that contradicts them. And this is incredibly important in today's world, where we're constantly bombarded with information from various sources, and it can be challenging to discern what's accurate and what's not.
So, if you come across a news article that challenges your political views, your ability to inhibit those pre-existing beliefs and objectively evaluate the evidence presented is crucial for forming an informed opinion.
Exactly. If we're too rigidly attached to our prior beliefs, we might miss out on important information or misinterpret evidence that contradicts those beliefs. Inhibition, in this sense, is essential for critical thinking and intellectual humility.
So, to bring this all together for you, the listener, the key takeaway is this. Executive functions are not just some behind-the-scenes mental processes. They're active and essential players in how well you understand everything you read. They're like the conductor of the orchestra, coordinating all those different cognitive instruments to create a harmonious symphony of meaning.
And we hope this deep dive has provided some valuable insights into how updating, inhibition, and shifting specifically contribute to that process, helping you navigate the often complex world of written text.
And as a final thought to ponder, we encourage you to think back to a recent time when you were reading something and found it particularly challenging to understand. Could it be that you were having difficulty keeping the information straight in your mind? Maybe holding on to some initial assumptions too tightly or struggling to see the information for a different perspective? Could those difficulties with updating, inhibition, or shifting have played a role in that struggle?
By becoming more aware of these cognitive functions and how they operate, you can become a more strategic and effective reader in all aspects of your life, from understanding news articles and academic papers to enjoying novels and engaging in meaningful conversations.
We encourage you to explore this fascinating area of research further, or simply take some time to reflect on your own reading experiences in light of what we've discussed today.
And we'll continue to delve into the ongoing discoveries about this fascinating connection between our minds and the written word in future deep dives.
Stay tuned.